Spare parts in oil and gas aren't simply items sitting on warehouse shelves. They can determine whether a critical asset keeps running, whether a shutdown stays on schedule, and whether an unexpected failure becomes a production event. Upstream operations often deal with remote assets, difficult logistics, and long replenishment times. Midstream operations add another layer of complexity, with pipelines, compressor stations, terminals, and inventory distributed across large geographic networks. Downstream operations are different again. Refineries and petrochemical facilities can contain thousands of assets and extremely large spare part inventories, all supporting tightly connected production processes. And this is where several spare parts challenges become deeply interconnected. Let's take a closer look at what these challenges actually look like inside a downstream operation. First, not every spare part carries the same operational risk. A low-cost gasket protecting a critical process unit may be more important than a high-value motor that can be sourced quickly. That's why criticality assessment matters. Maintenance teams need to understand which components can stop production, which failures create safety risks, and which components can be repaired. High-value components may enter repair cycles, while consumables are typically replaced. And as equipment ages, another risk emerges. The asset may operate for decades, while components may no longer be supported. A routine maintenance event can suddenly become an emergency. In large facilities, duplicate spares accumulate over years of upgrades. The same component may exist in multiple locations unknown to the team. If teams can't find the existing spare, another is purchased. Inventory grows, working capital gets tied up, while other sites carry excess stock. Inventory optimization isn't about reducing inventory at all costs. It's about determining the right quantity in the right location, based on criticality, demand, and lead time. Managing these categories correctly improves availability without simply increasing total inventory. A spare sitting on a shelf isn't automatically usable. Bearings require handling, motors need testing, and seals can degrade over time. The real question is not whether the part exists, but whether it will actually work when you need it most. Even the best strategy depends on supply. Specialized components can have lead times measured in months, often depending on proprietary OEM sources. Supplier disruption adds uncertainty. Quality, traceability, and certification become critical when turning to alternative sources. Documentation is as vital as the part. When the required spare isn't available, emergency procurement becomes the fallback. With expedited shipping and premium pricing, the cost of the spare is no longer the main issue. The cost of waiting is what truly impacts the bottom line. Nowhere is readiness more visible than during a refinery turnaround. Thousands of activities must be completed within a tightly controlled window. Every spare has to arrive on time. One delayed component can stall a maintenance activity and affect the entire restart schedule. These challenges don't exist independently. Criticality affects inventory decisions. Inventory affects availability. Lead times affect safety stock. Equipment lifecycle affects obsolescence risk, while supplier risk affects procurement. Turnaround schedules bring all these decisions together. Spare parts management is not simply about controlling inventory. It's about understanding operational risk and preparing for uncertainty. From upstream to downstream, the objective remains the same. Make sure the right spare is available when the operation needs it. Because in oil and gas, the right spare part isn't just inventory. It's part of keeping critical assets running.